Hello, good morning to all my students. Okay, today I will continue to the same topic, but this one should be the last one, part 3, about the 4.1. Okay, morning, Iru. Okay, how many is live now together? We got 12 students is watching now. I don't know the 12 student is in my class student. Okay, so today we just want to complete about the lesson 4.1. Okay, Sharon, morning. Okay, there's a force on a carrying conductor. Okay, magnetic field. Okay, still the same topic, but this one should be the part 3 lah. Part 3, that means I need to conclude. Okay, one more thing is I already upload the Google Classroom about this module. That means the exercise together with the tutorial. So hopefully the student can be download and also can solve it after this lesson. Okay, morning, Hari. Okay, so from here, I want to continue for this one. Okay, let's see what is this. Okay, first one, we need to find out factor. Okay, the factor that will affecting the speed of rotation of the electric motor. Remember the electric motor? They got commutator, they got carbon brush. After that, you need to using the Fleming left hand rule to find it, the coin how to rotate. Okay, the coin is either rotate in clockwise or either rotate in anti-clockwise, either one. Okay, so from here, Yuru, I start so long already. Actually, you can listen me or not? Can or not? Okay, because City here morning. Okay, can listen me or not? Okay, I need the response from the student. So if you can listen me, then I will continue to my lesson. Okay, can Okay, so I just continue to my lesson for the factor how to make the rotation become faster. Actually, before I want to start, actually you can think about how to make the rotation become fast. So you take out your Fleming left hand. Okay, rotating become fast, understood, sure is a force. Agree or not? Force bigger than the rotation become faster. Okay, so you take out another finger. So you got two fingers some more. That one is a factor. So sure one is the first finger, that's a magnetic field. So if you're using the stronger magnetic field, understood, the force will be stronger. So the rotation become faster. Number two is your current. You increase your current. How to increase the current? Use the high voltage. If you're using the high voltage, means your current should be higher, floating to the coin. So your coin also rotation become faster. So these two is already from your Fleming. You can find the answer. Okay, now we go through the factor. Okay, this one is one of the activity that from your textbook. There's a 4.6. Okay, we need to study the factor that will affect the speed of rotation of the electric motor. Okay, direct current motor, we're using the direct current power supply. Okay, and also pair of the magnet. Okay, now the insulator copper wire, we're using insulator copper wire. Okay, the center orange color one. Okay, after that, they tell you the SWG, that's a 26. That means you fix. Uh, Chaya, we got right rules. Left and right. This one, we learn about the left first. Okay. Then the 4.2, we learn about the right. Okay. Don't be so hurry. Wait, later first. Okay. We go to the left first. Okay. Left, the situation is the question provided the current. Then they tell you what's the magnetic field. Then you show about your force. That one is a Fleming left hand. That means you need to find out the motion of the object. Okay, where they go. Okay, right hand is generator. Generator means what? You need to move. After that, produce current. That one we call generator. Okay, just like the transformer. That means you need to move, then they generate electricity. That one is the right hand. Later, so we go through the left hand. We finish the left hand first. Okay, so for this one, we need to using the insulator copper wire, two large paper clip. Okay, paper clip, you want to clip the wire later, two of the thumb tag and also the connecting wire. Okay, the thumbtack they want to hold become something is a hook shapes. That means later your copper can be hooked at the thumbtack there. Okay, then we go through to the thumbtack is here. The join with the connecting wire. That means the thumbtack can conduct electricity. After that, go to up, become one of the hook. Okay, hook shape. Let all the copper wire can hanging on there. Okay, after that, they will on the power supply. That means the thumbtack also got current. Okay, then but at the bottom they put one of the bar magnet. So later we see what happened for the copper wire, because copper wire already got conducting electricity. Then after that, the permanent magnet also got magnetic field. Okay, so that means they got interaction already. After that, we're going to see what happened for the copper wire. Okay, safety precaution when you do this one experiment. Okay, switch off the power supply immediately after the observation. That means you cannot straightforward on the current. Although you go and see the rotation already, then you still keep to going to on the battery, on the power supply. Actually, there's a one of the problem, because the heat will keep given to the copper wire. So when the heat just given to the copper wire, they will heat up. So that means they normally call you to off. After finish one set, you go to off. So the current will flow only short time. So the coil will not become too hot. Okay, some students, you call them to using 6 volt. They don't want to listen. They're using 12 volt. Later, they will see the copper wire become red color. Red color, they're so excited. Then you call me, come and see. Please, don't do this all dangerous, the procedure. Okay, call you using how many volt, then you're using how many volt. So that means after you finish the observation, then you're off. Don't keep to on the power supply. Okay, now we're going to see the procedure, the setup. Okay, adjust the voltage. Okay, you adjust the power supply. 4 volt. Turn on the power supply and observe the speed of rotation of the motor. Okay, now you repeat. Chain becomes 6 volt. Okay, add one more another magnet. So this one is a another magnet. You add one more. Okay, make it become stronger. So to produce a stronger magnetic field, turn on the power supply and observe the speed of rotation. So that means speed you can see like become faster or slow. Add more turns of the copper coin. So this one copper coin is a turn. If you make the turn become more, you also need to observe what happened for the turning speed. So that means we adjust 3 of the responding variable, manipulate variable. First one, we go to make the current become stronger. That means you increase the voltage. Number 2, we go to make the magnet become stronger. We add the magnet. Number 3, you make the turning coil of the copper wire more turning coil. So you can see what happened for the speed. So this one is a 3 thing you need to adjust for manipulate variable. Responding variable only one. You want to observe the speed of the rotation. So one of the example of the experiment. Okay, you can see the design. They're using the paper clip. Okay, after that, the thumbtack is put at the bottom. You want to fix the paper clip, don't be moving. Okay, then you join the wire to the thumbtack. To the paper clip, not thumbtack. You just join together with the paper clip. Then after that, the paper clip just like the holder. The hole, you put the copper wire just on the thumbtack, on the paper clip, not thumbtack, paper clip. Then the bar magnet you just put at the bottom. Okay, at the bottom they also got magnetic field already. So that means when you just on the power supply, so that means we see what happened. Okay, you can observe when it just on. Okay, you need to start to move first lah. So that means you can find it. They will start easily to be rotating. When I just off, no more already. That means this one should be the current that pass through the conductor. That means they got magnetic field. Okay, they got interaction between two magnetic field. Then they start to produce the force. Then they start to rotate. Okay, this was one of the simple experiment only. You're not only using the power supply. Actually, if you're using the battery, you also can be produce it. So today I will introduce one thing you need to do. Okay, not exactly the project lah. I just want to see one of the activity you need to do by video clip. Okay, later I explain for you what you need to do. Okay, now we go through to see the discussion. Just now you see the diagram, is it? So from here we go to answer, what is the relationship between the current in the coil and the voltage supply? Okay, so that means they ask you relationship current and voltage lah. They understood the voltage when you supply more, the current also high. Agree, yeah? So from here we find it, the larger the voltage, the larger the current. Okay, normally we mention the voltage first because voltage is from the battery. Okay, now you need to describe the change in the speed of rotation of the motor when the voltage supply is increased. When you make the voltage become higher, that means I'm using a 3 battery, okay, compared to 1 battery. Understood, the speed rotation must be increasing lah. Okay, if I make it the strength of the magnetic field increase, how to make the strength of magnetic field increase? Okay, so this is one of the question. Student, please answer me. How to make the strength of magnetic field increase? Okay, I want to make it. Then I want to see is it the rotation become faster or not. So how I make it? Okay, what procedure I need to do? I make the strength of the magnetic field become higher. Okay, any idea? How to make this one become higher? Okay, just now I want to increase the current, so I increase the voltage lah. So the current can be increasing. Now I want to increase the strength of magnetic field. So what you need to do? So anybody here can give me the idea? Okay, how to make the strength become stronger? Anyone? Okay, anyone can answer? Use the stronger magnet. Yeah, correct. Use the stronger magnet. That's one of the thing can make the magnetic field strength become stronger. Okay, correct, Kai Xian? Okay, if you say using the magnet, same magnet, but you make it become closer, also is a one of the thing can increase the strength of the magnetic field. Okay, okay, you can say about you using the stronger magnet. Okay, number 2, you can say about the distance between the magnet. You make it become closer. You also can make the magnet become stronger. Okay, so from here, if I make the magnet become stronger, the strength of the magnetic field increase. So what happened for the speed? I think this one every student also know. The answer should be speed of rotation also increase. Okay, C. C is a number of turn. Just now I show you the coin, is it? So you make the turn is more. Okay, you round the circle, you make the turn is more. Okay, so what happened for the rotation? Your answer also increase. Why? Because the number of turn, if you more, that means the current will go through more circle. When they go through more circle, that means you can find it the interaction between the current in the coin and also permanent magnet also increase. Okay, like this we can say they cut lah, because they're perpendicular, is it? So that means perpendicular, when they just rotate, they cut the magnetic field. Okay, permanent magnet got magnetic field, current also got magnetic field. When they just interaction, they will cut each other. How they cut? 90 degrees. When they just cut, you more number of turn, they cut more frequently. When they cut more frequently, that means they produce the force becomes stronger. Okay, so finally, the coil can be rotated faster. Okay, now we state the factor that will affect the speed of rotation. Just now the factor you can find out from the question number 2. First one sure is the current. Okay, you can say about the voltage lah. Okay, number 2 sure is the strength of the magnetic field. Okay, number 3 sure is the number of turn. Okay, these 3 is a factor how to make the speed of rotation of the motor become increasing. So let's see the answer. First one, current. Okay, number 2 is a strength of the magnetic field. Number 3 must be coil with more turns. Okay, so this one is a 3 factor how to make the speed of rotation become increasing. Okay, now we need to introduce these 2 types of the motor normally we using for turning coin. Okay, first one is a brushless. We don't have any brush. Okay, okay. Another one should be the brush motor. Okay, brush motor, that means they're just like the before that I told you lah, they got commutator, they got carbon brush, and that one is a brush motor. So we see the structure, what's the difference? Okay, they also got magnet. You can see the white color, this part should be the magnet. The coil, the turning coil, and that one should be the coil lah. Okay, so for this one brush motor, okay, The center one, this one, sure is a commutator. Okay, carbon brush is a side one. Okay, the black color, this one's a carbon brush. Okay, after that, the magnet is surrounded. Okay, surrounded the coin. Okay, remember the coin we learned before that. There's a magnet is a permanent, they're fixed at there. Okay, now we go and see what is the similarity for these two motor. Okay, both also got magnet, they also got a coin. Okay, because you want to using the function, the concept for the Fleming left hand. So they sure got magnet, sure got the coin, because they need to rotate, they need to cut the magnetic field. Okay, number two, what should be the same? They use the magnetic force to produce the rotations. Both also need to produce the force. Finally, the motor can be turning. It's the same concept. Okay, both also produce the same concept. Both also got magnet and also the coin. Okay, now we see what is the differences. Okay, for the brushless and also brush. Okay, so carbon brush, from here you can see brushless means they don't have any carbon brush. You can see this one is black color brush, is it? But this one is nothing. They only got coin, only got magnet. Okay, now we're going to see the function for the both motor. Okay, you can see this one diagram differences. What's the difference between the two motor? First one, coin is stationary. When they function, the coin is never moved. That means this one, you can see the gold color copper wire. This one is never move one. Which one move? The magnet rotate. The white color surrounding the round one, that one will be moving. Okay, magnet moving, coin stationary. Okay, brush motor is reverse. Magnet is stationary, but the coin is rotating. Okay, remember this one? We recall back what we learned about the Fleming left hand. You can see the motor, is it? Okay, you can see the coin is turning. Okay, but the carbon brush is a fixed, and also the magnet also fixed. The one we call brush motor. Okay, brushless means there are no carbon brushes. Then after that, therefore, there are no frictions. That means you know carbon brush. That means when I just turn, I'm not related for the carbon brush. I don't have any frictions. Okay, anything just block you to move, that one got frictions. So they don't have any friction between the brushes and also the commutator, because they don't have what? How got frictions? So that means carbon brush, they can save the energy lor. They no need to overcome the frictions. Okay, this one brush motor, they got frictions because they got carbon brush and also commutator. They will cause the carbon brush to wear out. Okay, when they just turning, they will touch. Second turning, they touch again. So that means they got the frictions. Okay, for the brushless one, if you know friction, then no sparking, because they never touch and carbon brush. No sparking at the commutator. Okay, they don't have any sparking, produce lost energy. But this one got, they produce the spark, okay, during at the commutator touching. And the last one, if you know sparking, that means your sound is soft lor. You don't have any the motor turning sound, got friction, some more got sparking sound. So for this one, the soft operational sound. Okay, how about the brush? They should be louder. Okay, louder and operational sound. So this one is the differences between the brushless and brush motor. So from here, you can find from here overall the brushless is better for the functions. Okay, compared to the brush motor. Okay, when something should be better, then you find out the cost must be higher . Okay, so we go through to the next part. Okay, you can see there how to function. This one is called brushless. That means you can see the coin is fixed. Only the magnet turning. Okay, the magnet turning, that means there's no need to using the commutator and also no need using the carbon brush. Only the magnet turn. Okay, this is a normal we see before there's a brush motor. You can see they got commutator and also they got carbon brush. Okay, you can find out now the coin is turning. The coin is turning. The magnet at the outside is a fixed one. Okay, the magnet don't have any movement. Only the coin is turning. You see when the coin just turning, they produce the frictions. And also you can see they produce the spark. Okay, So this all thing will make it become louder operational. Okay, so this one is how the both motor to be functions. Sure, both must have the magnet and also the coin. Excuse me. So this one is a differences between the two of the motor. Now we need to find out advantages for the this one brushless motor. That means they don't have any commutator and also the carbon. Okay, let's see what's the advantages. Okay, the brushless, they don't have any brushing one. Advantages, the first one, no frictions. Okay, first one, sure, everybody know no frictions. If no friction, that means they're high efficiency. That means they do not lose the energy. Okay, after that, they have lower maintenance cost. Maintenance cost, because you got friction, that means maybe the motor, they got something happen because they will got rusting. When you just turning, they got rusting, you must put some oil, then you need to service. Service should be the higher for the brush motor, but brushless, they say lower maintenance cost. Okay, you no need to every time oftenly go to service. And the last one is long lasting. Excuse me. Okay, lower maintaining cost, that means they for using time, using for longer time. That means they're also not oftenly go to service. Only one disadvantages, high cost. The cost must be higher. Because you say this one good, is it? So the cost must be high lah. Okay, so this one is what's the differences for the brushless and also brush motor. Excuse me. Okay, this one's a one activity I want you to do. You can refer your activity from the textbook. There's a 4.9. Okay, see, be careful what you need to do. You need to design one simple and efficient homopolar motor. Okay, they're using the neodymium magnet. Then you're using the double A battery and also the copper wire. Carry out this one activity in groups, but now you cannot in group. That means you are personal. So you need to gather the information of the homopolar motor from the aspect. Okay, first one, working principle. Okay, normally the working principle is for the turning coin. Okay, the concept from the turning coin. The shape and the size. Okay, shape and the size depends for yours. How to design. Okay, I don't care what shape you want. You want to turning coin also can. You want love shape also can. When you just type the homopolar in the YouTube, actually got so many different video can show you how to build it. Okay, see various design of the copper wire that can be tried out. So this one activity, you no need to write in PowerPoint. I just want you to do it in video clip. Okay, you want to convert PowerPoint to video clip also can. But what you need to put in the video clip, first one, how you go to design. Okay, how you want to design. Okay, you draw. Okay, number two, you go to produce the material. After that, you show, you snap photo or you take video, what material. Then every process you how to build, you need to sketch in video clip. Okay, you how to turn the wire, how you go to set up. You want fast forward also can, but important, I want to see the step, how you go to build. Until you finish your success. Okay, only you no need to write objective lah, how you go to find lah. This all thing you no need to show me. Okay, a different a little bit from your project. Just you need to show me is in the video clip how you sketch. Then after that, how you build, what material you want, and the last one is a product functions. All in video. Okay, all in video, no more PowerPoint. So I show you, this one is a homopolar motor. Okay, you can see bottom is a magnet. Then you put the double A battery above. Then they join the coin. Make sure when you build the coin, you must properly, the coin must be let the double A battery can go in. Okay, and also the bottom, they can touch the magnet. Touching the magnet. Then at the top, they got one of the straight line of the copper coin. They must touching to the head of the battery. Okay, if you cannot touching the head of the battery, that means you are no current. Okay, so the concept should be like this. So that means the coil later you build, they must touch the magnet. Okay, another side must touch to the battery. So that means the magnet can produce magnetic field. Then your coil also got magnetic field. After that, the interaction finally got motions. Okay, example, you can create the shape like this also can. Okay, depend for yours. Okay, I don't care how many shape you want to create. You want to rectangle also can. You want triangle also can. You want the love shape also can. Okay, when you just on the YouTube, they got so many things. That means you can refer how to build. Then after that, I want the final products. You show me how they produce. Okay, finally must be function. Don't tell me cannot function one. Okay, so we got example. The shape can be like this. Okay, we got coin shape. Okay, then after that, we also this one, let's say how to build. Put the double A. Then this one you must know how to turn. Okay, touching the magnet. After that, you touch, that can be turning. Okay, this one is one of the homopolar motor. They're using the concept of the turning effect by using the interaction to magnetic field. Okay, so understand what you need to do. So how long we need to do it? I give you 1 week. Okay, only 1 week. So that means you can start already lah. Okay, 1 week until the next Tuesday lah. Next Tuesday, that means you need to pass up the video clip how you go to build this all thing. Okay, so from here, this one's one of the activity you need to do. Okay, then we go through to the next part. Okay, next part already is a finish about your chapter 4.1. Then we go through the formative practice. Okay, let's see the formative practice. Okay, with the aid of the label diagram, explain the meaning of catapult field. Okay, I think catapult field you still understand. Catapult field must be produced when they got interaction between two magnetic field. One from the current carrying conductor. Number two is from the permanent magnet. Okay, when it just interaction, that means they produce a catapult field. Okay, let's see here. Catapult field is a resultant magnetic field. Okay, that means the final magnetic field. They're produced by interaction. Remember this one word you need to put. Interaction between the magnetic field from current carrying conductor with the magnetic field from permanent magnet. So this one we call catapult field. Okay, after that they say must label diagram. You need to explain and also with the diagram. So you just show the diagram. Okay, how to produce catapult field? You draw two bar of the magnet. After that, the magnet got the permanent got magnetic field. Okay, then center you put one current. I don't care your current carrying conductor is a dot or cross. Okay, important when you draw the arrow must be correct. And also the curve. Okay, this one if you're using the Fleming left hand, the current is far away from you. Far away from you, the force is go downwards. When the force go downwards, that means up should be curved. Okay, the line up should be curved and also closer. At the bottom, you find the line only one line only, and there's a less curve and further. So this one is how we go to draw the catapult field. Okay, number two, they show about arrangement apparatus for study the effect of the force on the current carrying conductor. Okay, this one same like before that we learned magnet, north to south. Then we got copper wire. Okay, sorry, this one's a copper rod. Copper rod, that means they can move one. Okay, this one, the red color, the track, that means also copper but cannot move, they're already fixed. Okay, we got current supply. Current supply must start from the positive. Okay, when it just move, we only want to see is a copper rod. How the current flow through the copper rod. Okay, now we want to answer one of the question. What is the direction of the current in the copper wire? XY. When the switch is off, the direct current power supply is turned on. Now you tell me the current how to flow. Flow X to Y or Y to X. Okay, so you answer me now. The current how to flow through the copper rod. X to Y or Y to X. Okay, I think when you see the positive, negative, then we know already how the current to flow it. Okay, yeah, correct. Cassian, X to Y. Okay, we know positive and negative, so we're going to see X to Y. Okay, so from here, there's a X to Y. Okay, we just see the positive. Okay, from here, they go to X to Y means far away from you. Agree, Far away from you. So that means when they're far away from you, then you need to show about your Fleming. Okay, so you need to show by yourself. Okay, later we check, is it the force correct or not? Okay, so you point by yourself the Fleming north to south. North to south means the first finger must be point up. Okay, point up. Second finger, that means the current is far away from you. You take out your second finger. Now your second finger point to the screen. That means don't point yourself. Point to the screen. Okay, now you're going to see where is your thumb. Okay, anybody can tell me where is your thumb if you're using the Fleming left hand rule. Okay, you need to point by yourself now. You tell me where's the force acting to the copper rod. Okay, to the right or to the left. Okay, we either left, either right. So from here, anybody can tell me your answer? You point by yourself. I don't want to show you how to point. You just take the north to south, you point your first finger up. Okay, up already, then you lock the first finger. Don't change already, always up. Take out your second finger, then you rotate far away from you. Okay, far away from you. Then you take out your thumb. Where is the direction of your thumb? Left or right? Okay, anybody can tell me the answer? Okay, Sharon tell me to the right. Okay, the rest? The rest? Right. Okay, yeah, correct. That's a to the right hand side. So that means later you can find out the rod, the copper rod that will move out to the another magnet. That means they're closer to the battery because they go to the right. Okay, Linghan also correct, Yiru also correct. So from here we go to see the next question, what they want. Okay, they say explain. Okay, explain to the motion of the copper wire. Okay, explain the motion of the copper wire, X, Y, and state the direction of the motion. So we go to explain the motion of the copper wire. The motion sure the X, Y, this one copper rod, the sure will move lah, is it? Then after that, you need to state about the direction. Just now the direction you tell me already, go to the right, is it? So from here, if the question is 2 marks, you answer like this, is it correct? Okay, that's the correct one, 2 marks only. If the question is a 4 marks, we need to add the info. That means the info where you want to add, you add about why the copper wire can move. You need to add the info why the copper wire can be moving. Okay, this one you just can say they can move, but if 4 marks, you need to explain the process, how to make the XY copper rod can be moving. So you need to talking about the current carrying conductor, then you need to talking about the interaction, then produce catapult fuel like this. This one is a process. So from here, I just think about this one is a 4 marks. So we just go to answer. The current in the copper wire XY produce magnetic field. Okay, that interaction with the magnetic field from the permanent magnet. So this one is the first sentence I need to mention lah. Okay, I need to mention 2 magnetic field, how to produce. Okay, number 2, you must say the interaction ready, they must got catapult field. Okay, so the 2 magnetic field combined, they produce catapult magnetic field. Okay, after that, the sugar gases. Okay, they will produce the force. So from here, the catapult magnetic field exert a force on the wire XY and move the wire. Okay, so until number 3, we mentioned about the motion. Okay, XY can be moved already. Okay, the last one, directions. The direction of the motion of the wire go to the right hand side. So finish. So this one should be the 4 marks answer. Excuse me. Okay, then we go through to the number 3. State the 3 factors that will affect the speed of rotation. Okay, 3 factors. That means you need to know, just now I told you how to make the rotation become faster, because only three. First one is a current. Number two is what? Okay, I tell you current. Number two, you tell me what should be the answer. Okay, anybody here? First is a current. Number two. Okay, I want to see the student go follow the lesson or not. This one already mentioned. The factor how to make the speed rotation become higher. First one is the current. Then some more. Okay, we got 24 watching now. Okay, what's the following answer? Just type there. Okay, hold on. Stronger magnet. Yeah, stronger magnet means the strength of the magnet increase. Okay, stronger magnet. Okay, strength of the magnetic field, correct, from Yiru. Okay, number three, last one. Last one. Okay, beside the stronger magnet, beside the strength of the magnetic field, what should be the last one? Yes, turn of the coin. Number of turn of the coin. Yeah, correct. So that means now we go to show current. Number two, strength must be strong. Okay, last one, number of the coin, turning coin. Okay, so these three should be the factor. Okay, now we're going to see number four. Number four, we compare and also contrast the structure of the brush motor. Okay, we got brushless, we got brush. Okay, now we're going to see the first one, brushless motor. Then another one should be brush motor. Okay, structure. Structure, that means we know both also got magnet. Both also got the coin. Agree, yeah? Okay, how they function. So the first one, we can find it. Brush motor is the coin stationary. The coil is maintained stationary. Only the magnet to rotate. Okay, how about the brush motor? Brush motor is terbalik. Okay, the coil go to rotate, but the magnet is a permanent magnet. So this one is what we can contrast about the function, the structure, how they're moving. So the first one, we just mentioned the both consist of the coil and it's also permanent magnet. Okay, this one is a structure. Okay, how they go to move it? Brush motor, the permanent magnet is stationary while the coin is rotate. Okay, the brushless one means the coin is stationary, the magnet is rotating. So this one is how they go to start to move it. Okay, now we need to say about advantages lah. Just now we all learned already about the advantages. Compare the brushless and the brush. Okay, first one, we just mentioned no frictional force law. No frictional force, that means they can reduce the operational sound. Okay, number two, we just talking advantages, don't talking disadvantages. Okay, lower maintenance cost. You also can say high efficiency, or you say last longer. Okay, for the brushless motor compared to the brush motor. Okay, so this one is the advantages. Okay, we got example question. Okay, let's see the example question here. Okay, they show about the compass needle directions. Okay, you can see the diagram here. They got compass needle surrounded with the current wire. Okay, they got compass S and also the compass T lah. We got two compass. Okay, when they just switch on, we see what happened. When you switch on, that means the current now is go up. Okay, for this part, we see the current is up. So this one, you need to using your right hand grip. Remember the right hand grip. So the current is up. You tell me is clockwise or anti-clockwise. Okay, how the wire turn. Later we show there's a circle, is it? But we need to know direction of the magnetic field. Now the magnetic field is clockwise or anti-clockwise? Okay, anybody here can answer me? When I put the compass, you see the direction is a clockwise or anti-clockwise? Use your thumb to represent right hand. Now it's the right hand, not left already. This one only current. Okay, so what's your answer? Okay, anti-clockwise. Yeah, correct. Anti-clockwise. Okay, using your right hand thumb your thumb point up. So then should be anti-clockwise. Okay, so now the first question, when the switch is on, now you need to indicate with an arrow the direction of the current in the circuit. So first one, you draw circle. After that, you show about the current, there's an anti-clockwise. So this one should be the answer lah. Okay, so you show the arrow, there's an anti-clockwise. Okay, question number 2, you need to find out the indicate and arrow the direction of the compass needle of the compass T. So this one is a compass T. Okay, you need to show the needle how to point. So this one normally anti-clockwise. So you put at the fore part. Okay, at the top one sure is go to the left. Okay, if you put the compass is the left hand side, they sure will go to down. Okay, T must be go to right lor. Then this one another compass should be up. Okay, so I go to show for you. If I put the compass surrounded with the current, then should be like this. Okay, this one is a T, go to right. Then this one compass is up. If I put one more here, they go to left. This one will down. So you can see that one of the circle is anti-clockwise. Okay, if the question like this, that means you need to draw. Okay, continue the same question. B, name the rule we use to determine the direction of the magnetic field. Just now you give me the answer anti-clockwise. You using what rule to find it? Okay, anybody here can answer me what rule you go to use? You must know the name. Not only the answer, you must know the name, the rule you use it. Okay, what's the answer? Okay, we just see the question can answer or not. Okay, the rule we using for these directions, anti-clockwise. Okay, the spelling must be correct. Okay, we see which student can be answered this question. The rule we using for the anti-clockwise. How you know there's an anti-clockwise? Okay, anybody? Okay, just a simple question. You can answer it. Okay, what is the rule we using? Right or left? Right or left? So you have to answer. Maybe the line got problem. The student so slow today. Yeah, I get it, Mei-Ling. Right hand grip rule. Okay, so the answer is right hand grip rule. Okay, remember the name, not just only for the anti-clockwise. You need to know the name. Okay, then we continue to the next question. Okay, number 2. Number 2, they show you about the current carrying wire placed between the two opposite pole. Okay, two magnet. Now the wire that will swing upwards. And you can see the swing upwards. Name the rule we want to determine the direction of the force. Now it's another situation. What rule you go to using to find out the direction of the force? You can see this one, up is a north, down is a south. Okay, now they say the force turn out, the force go out. So the current is come to you. So you tell me how you find the force can be up. What rule we using? Okay, again, you tell me the rule. What's the rule? Okay, just type there. Don't be lazy. Order more 3 or 4 words only. You just type. What's the name of the rule we're using for these one situations? Okay, yeah. Or then 3, Fleming left-hand rule. Okay, we're using Fleming left-hand rule. Okay, so this one should be the answer lah. Fleming left-hand rule. Okay, now we continue for the next question. State one of the electrical appliances that uses the rules for the A above. That means you just mentioned one of the electrical appliances. They're using the rule of Fleming left-hand rule. So you just think about what is the electrical appliances in your house that's using for motor turning. Okay, motor turning. So this one, motor turning, anything just turning for the magnet and also conductor coil, that one is related for the Fleming left hand. So the simple one, we know there's a fan. Okay, fan sure is a motor turning. Okay, number two, you can say about your juicer. Okay, your blender. Blender also using the motor. Okay, another one you can using your washing machine. Your washing machine also turning one, is it? That one also using the this one, the Fleming left hand rule. And the last one, drill. The drill, want to drill the screw go into the wall. That one also same. So from here, there's just one. So I give one enough. The simple one, there's a fan. Okay, now we're going to see the 2.1, they draw. Okay, we need to draw the resultant magnetic field produced. Resultant magnetic field. So that means we need to show about this one diagram. North to south, then you point downwards. Let's take out your first finger, point downwards. Okay, now take out your second finger. We just focus this one line. The current carrying conductor for the wire between the magnet. Okay, you can see the arrow is come to you. Can you see the arrow come to you? Okay, now you point downwards. You point downwards. Okay, Muhammad Shukul, electric fan. Yeah, correct. Just now the answer. Okay, the current is come to you. First finger point down. Second finger take out. Then turn your second finger, point yourself. Point yourself. Now you take out the thumb. The thumb is go to right hand side. So that means correct lah. Then you see the coin that lift up. The coin swing to upwards. So that means now I need to draw. I need to draw the catapult field. So that means when the force is go to right hand side, which part should be curved? The left hand side, when you draw the line, must be curved and also closer. Okay, electric car. Okay, we're talking about the electric car. Yeah, because inside they got one of the motor that be turning for the electric car. Okay, so this one we go to draw first. And south, north to south. Then I go to curve. I curve to the left hand side, the magnetic field. Then the center one should be dot, because dot means come to you, is it? So that means now the current is come to you. So you show there's a dot. And D, the last one, they call you to draw so the force is acting right hand side. So we put F. So this one is answer for the C and also the donkey. Okay, then we go through to the next part. That's the number 3. Okay, number 3 is one of the one part of the essay question. So essay question, you remember, you need to put the table form, you need to choose. Okay, now they show you 3 of the motor design. X, Y, Z. Okay, let's see what is that. This one for the small portable fan. Excuse me. The fan should be rotating. After that, you're going to see the 3 different. Okay, the first part, I go to zoom first. Okay, you can see this one. Okay, the flame blade. This one's a flame blade. Number of turns they're using 50 turns. Okay, understood lah. 50 turns. We compare the next one. Is it 50 turns or not? Okay, after that, you're using battery. Battery, you see got 3 battery. Okay, how about the shape of the magnet? There's a semicircular shape. Semicircular shape, you can find it, they're more focusing. You can see there's a curve. After that, the magnetic field, they're more focused at the center because the curve shape, is it? Okay, we compare to the second one. This one is a motor Y. Motor Y, the number of turns, only 10. Understood lah, only 10. That means the catapult field become weak already lah, because you only 10. Okay, after that, the fan blade also like this. Okay, this one using rectangular shape. Okay, rectangular shape, that means they still got magnetic field, but the magnetic field is not focused. Okay, they're just only straight line lah. Okay, battery, only 1. Okay, battery only 1 means the current become less already compared to just now one. Okay, so from here, we got 2 motor. Okay, 1 more. We got 3 motor, is it? Now it's an electric motor Z. Okay, we go to see the Z. Okay, The fan blade, still like this. Number of turn now is a 50. Battery also 3, but this one using a rectangular shape. Okay, now you tell me which one should be the most suitable to let the motor to turning faster. Okay, after you see 3 of the motor, okay, so the question should be asked you lah. So now you're going to see what you want to do. State the suitable characteristic of the electric motor that to be used to rotate the fan blade in greater speed. They want fast. First one, you tell me number of the turn of the coil, what you want. Okay, remember for this kind of the question, although they say 50, although they say 10, we no need to mention the number. We just say I want more. Okay, more or less only. Okay, number of the battery, you also no need to say I want 3 battery, I want 1 battery. You just say more battery. Okay, more battery should be better lah. Okay, number 3, shape. Shape you can copy from the question. You want the semi. Okay, the semi-shaped permanent magnet. Then you need to explain why. So this one question only 8 marks. So that means number of turn 2 marks, number battery 2 marks, the shape of the permanent magnet also 2 marks. Last one, you need to choose. Choose the which one should be the best. After that, explain again. So that means this kind of the question, please, table form. One part you write characteristic and then part you write explanations. Okay, so from here, I just show you number of turns. I sure I need more. Okay, if more number of turns means I can produce higher the strength of magnetic field because you can cut it. Okay, you can say higher force to produce also can because later the permanent magnet I need to using strength. So I better don't crash. So this one the coil are using force, more force. Okay, battery that means you can say about more current. Then the shape permanent magnet you can say about the strength become stronger. So from here, we're going to see which one we need to choose. Okay, we lock the 50 turns, 10 turns out. So Y no need to see already. Okay, now we compare X and Z. What's the difference? Only the shape is a difference. So I want the semicircular shape. So finally, I want to choose is a X. Okay, don't choose first, write first. Write the characteristic. Show this as a table form. I need to increase the number of turn. Or you say I use more number of turn. Don't mention how many. Then why? Increase the strength of the magnetic field you can use, but later you need to use also, but don't crash. We can using increase the force. Number 2, increase the number of the battery. Then increase the current. Last one, I want the semicircle shape. Reason, increase the strength of the radial magnetic field. Radial magnetic field means the curved one. The curve, the shape of the magnetic field become closer at the center. So we call it as a radial magnetic field. You also can using the strength of the magnetic field. So this one is a 6 marks. And the last one I need to choose. X is the chosen. Okay, after you mention X is a chosen, 1 mark. Okay, then repeat because, okay, copy from the characteristic. Having great number of turn, more number of the battery, and the last one, semicircular shape of the magnet. Okay, reason no need to repeat, only repeat the characteristic. Okay, so this one's a one part for the essay question. Okay, so our lesson just until this part. Okay, so what you need to do is, I got sent about this module in the Google Classroom. You need to download and also solve the tutorial question. Okay, after that, no more. Thank you for your watching. Okay, I got share about the Google form. Okay, Google form, you need to solve it for today attendance. And also remind you must using MO email, don't using Gmail. Okay, if the student never enter about Google form, I just assume you ponting my class. Okay, just thank you for everyone to watching for my today lesson. Okay, everyone, bye. Okay, bye. Got any question, you can PM me. Okay, bye.